Okay, this is the P3 paper from June 2021. It's question number 9, which is the last question on the paper. And if you look at this, you can see this is work on trigonometry. It's the trig addition formulae. We're in particular going to be doing these simplifying a cos x plus or minus b sin x. One of those questions. The first part, always relatively straightforward, and then they can really get quite creative in these parts around sketching them, finding the maximums and minimums and so on. We'll see how we get on with that. So part A, as I said, is relatively straightforward. If you've done any work at all with this, you should be absolutely fine. They've said, can we express 12 sin x minus 5 cos x in the format of r sin x minus alpha? So this is sin A minus B, and sin A minus B is sin A cos B minus cos A sin B. So just applying that means that I'm going to get 12 sin x minus 5 cos x. We don't do anything with that side, but this side, multiplying that out or expanding that, gives us r sin x cos alpha and r cos x sin alpha. And then what we do is we equate the coefficients. What does that mean? What that means is if I look at this first term here, I've got sin x there and I've got sin x there. So 12 must be the same as r cos alpha by equating the coefficients there. So if I do that, then we get 12 equals r cos alpha, and doing exactly the same thing with the other one, I get that minus 5, I guess, minus 5 is minus r sin alpha. We're not going to write that down. The negatives take care of themselves. We're actually just going to write down that 5 equals r sin alpha, and I'm absolutely used to this. This isn't a surprise to me that I end up with those two simultaneous equations, or that I'm going to do 2 divided by 1 to tidy this up. When I do 2 divided by 1, I get sine over cos, because the r's cancel. Sine over cos is tan alpha, and I get 5 over 12. So I get tan alpha is 5 over 12. From that, alpha then is the inverse tan of 12. Do that on the calculator, and if you haven't already remembered, go back and check. It wants alpha in radians, and it wants it to 3 decimal places. So pretty standard stuff. We've now got to work out the value for r. Again, r is equal to, absolutely standard approach to that, it's going to be this squared plus this squared square rooted. I don't do any more work than that. I don't explain it. Don't need to. This is more than enough to be able to just say that it's 5 squared plus 12 squared square rooted. And hopefully some of you will recognize they're using numbers that you should be able to see. A 3, 4, 5 triangle, 5, 12, 13 triangle, a 7, 24, 25. They're Pythagorean triplets. You don't need to because you can do it on the calculator, but it'd be useful if you start remembering some of those things. Okay, that's r and alpha. Make sure we actually answer the question. The question said 12 sin x minus 5 cos x. And it said write it in the form r sin x minus alpha. So that's 13 sin x minus, and we said it was 0.395. So that's actually the answer for part A. What does part B say? Yep, so let's just spend a couple of seconds just looking at this. For part B, and even part C, but for part B, we're looking to see 12 sine minus 5 cos, and I've got 12 sine minus 5 cos. So when I'm trying to do any work on that, the bit that I've just highlighted in blue, for example, if r is equal to 13, which it is, it means I know the maximum and minimum values of what's highlighted in blue. It's going to be 13 and minus 13. That's one of the good things about being able to rewrite it in that format. They're asking us for the minimum value of g theta. So So let's just have a proper look at g theta here. Yeah, okay, so if I want the minimum value, I'm doing 10 plus something. I want that to be the minimum value of my 12 sine x minus 5 cos x, because then 10 minus that, it's going to be minus that, will give me a g min as well when we're actually going ahead and doing it. Okay, I've explained that to you. I need to now explain that to the examiner if we're doing it. So B, part 1, g theta is equal to 10 plus 12. It's quite complicated, isn't it? But that's okay. It doesn't cause me any problems. 2 theta minus pi over 6 minus 5 cos 2 theta minus pi over 6, which is 10 plus, rewrite that using the work that we've just done then. So theta r sine x, which in this case is 2 theta minus pi over 6, that minus 0.395. And then we can say for g min, we want minimum value of 13 sine 2 theta minus pi over 6 minus 0.395, which is equal to minus 13. So g min equals 10 minus that 13 works out to be minus 3. So just to make that absolutely clear, the smallest value that can be is minus 13. So the smallest value that all of it can be is 10 minus the 13 is minus 3. Okay, G part 2 asks, when does that happen? Well, that happens when, I'll just explain it to you and then we'll go through and write it down. That's going to happen when that bit there, when the sine works out to be minus 1. So that's when it's going to occur, and then I just need to solve that equation. So occurs when sine 2 theta minus pi over 6 minus 0.395, when that equals minus 1 is when we'll get the value of minus 13. When does that equal minus 1? When the angle is equal to 3 pi over 2. We're working in radians. When the angle is equal to 3 pi over 2, 270 degrees. Think about what sine looks like. Okay, sine looks like that, doesn't it? So it's at that point there, theta equals 270, or theta equals 3 pi over 2. So in this case, it's 2 theta minus pi over 6 minus 0.395 is equal to 3 pi over 2, and then just rearrange all that, okay? So add on the 0.395, add on the pi over 6, get that answer, divide it by 2. It works out to be 2.82, and just check that it does say, no, it doesn't say anything, so it's up to me as to how accurate I make it. So I've done it to 2 decimal places there, but theta basically is equal to 2.82 radians in that case. Okay, on to the last part then. So similar, we've got this nasty little squared business in here, and again it's a matter of using our common sense. Only worth 2 marks this, the last bit was only worth 3 marks here. So let's think it through before we actually go ahead and do it. They want the range of values of a function, h beta in this case, which is 10 minus our function that we've got. Our function squared, but still our function here. So what you need to think about is, how am I going to get the maximum and minimum for 10 minus something squared? And if you're not careful, if you're not thinking about it, we're not going to put 13 and minus 13 in. And if you did put 13 and minus 13 in, when you actually do it, the value for 13 and the value for minus 13 going in there are both going to give us 169 because it's squared. So 10 minus 169, yeah, that's going to give me, or give me my minimum value. But what about my maximum value? Well, my maximum value for H should be trying to take away, if I want the maximum value, trying to take away as small as possible. Well, the smallest thing that this can become, the smallest thing I can take away, because it's squared, the smallest thing that can be is 0. Think about what y equals x squared looks like. Y equals x squared looks like that. The smallest value that y equals x squared is 0. So when I'm going to be doing that, the maximum value that h can be, because the smallest I can take away from it is 0, it's going to be 10 take away 0 is just 10. Right, let's just write all that down, and while I'm writing all that down, make sure that I'm making it clear enough to the examiner. Although, to be honest with you, in terms of the examiner, there's just 2 answers for this. So if I've got h beta, which is 10 minus, how did I have it written down? 10 minus 12 sine beta minus, sorry, I've forgotten what it looks like, minus 5 cos beta squared, I would simply say, in order to make it the minimum value for min h beta, here, subtract maximum value. So h beta is going to be 10 minus 13 squared, which is going to be 10 minus 169, which is going to give me minus 159. That's the smallest that h beta can be, because I've taken as much as possible away from it. And then for the maximum hb, subtract smallest value, which is going to be h beta is equal to 10 minus, and it's just going to be nothing squared, which gives me 10 minus nothing gives me 10. So range of h is going to be between 10 and minus 159. As I say, the 2 marks really are just for the answer there, so all of that is just explaining it to you and making sure I'm happy with the thought process of it, but the final answer is the final answer there. Okay, that's the end of that question. That's the end of that paper. Hopefully that all makes sense.